Good morning, ladies and gentlemen. It is Mr. Manta here. Surprise, surprise, I'm sure. Welcome to our video lesson for today. Today's date should be Thursday, April 16th, and we're moving right along in our Unit 6 Chemistry unit. Yesterday we talked a whole bunch about properties, and today we're going to take that one step further and talk about actually using properties. But first, we are starting with a do now. Ladies and gents, make sure you take out your notebooks, have a pencil at hand, give yourself today's lesson heading, and write out a do now with 4 spaces for answers. Here are the 4 questions. Pause the video and answer these 4 questions in your science notebook now. Alright, I'm assuming that you're now unpausing and we are moving on because I'm going to show you the answers. So you got to have yours down to see if you got them correct. Number 1. All matter is made up of particles. We talked about that a couple days ago, that if you could zoom in super major special close to any kind of matter, you'd see it's made up of tiny little particles. Number 2, you can find an object's properties by either measuring or observing. This is the 2 ways we talked about learning about an object's properties. Yes, it kind of corresponds to quantitative and qualitative observations. Number 3, in the crash course video, Sabrina used a tape measure to measure the block's length, width, and height. And number 4, a scale measures the property of weight. I'm hoping we did pretty well in these 4 questions because these are the 4 questions that the most people missed from yesterday's independent practice. But since you got a chance to see the answers afterwards, you should have done a little bit better on these 4. We're going to move right along and make sure that we pick up where we left off yesterday. Because I made a promise to you guys at the end of the video yesterday. We talked about how first we talked about properties, but then I also brought up that it seemed like this whole idea of properties was almost like too easy, like it was a preschool concept or something, and that you might be thinking, did we really need a whole lesson on this? And I was going to explain to you today why we needed a whole lesson. In fact, I left you with a cliffhanger that looked a little bit like this, that we would find out next time in science class why we need to talk about properties. So let's do that. Here is why we talk about properties and why we're taking, so many video lessons to go over this big idea of properties. First of all, in science, people often discover new things that have never been seen before. This is exciting. A major thing that goes on in science that makes it so cool is people discover new things. We have to figure out what they are. It's one of the most exciting things that can happen, a new mysterious discovery. When we find something new, we try to figure out what it is. Now, if you're like, Mr. Manta, what the heck are you talking about? I have 4 examples that I can show you of times that scientists have discovered something new and they need to figure out what it is. So, as you've probably known since you were like a kindergartner, some of the most exciting scientists in the world have the job of digging up dinosaur bones. So this is an actual picture from a site in France where some paleontologists, that's a scientist who studies old bones of dinosaurs, dug up this giant old bone out somewhere in a field in the middle of nowhere. And of course, the first question that you and I might be asking is, well, what is it? What kind of animal? Is it a dinosaur bone? Is it a mammoth bone? What kind of dinosaur would it be? Would this thing come from? That's an example of a time where scientists discovered something new and they don't know what it is. It's a very strange picture that you're probably looking at here. This is an object that some astronomers recently found way out on the outsides of our solar system, even past Uranus and past Pluto, on the outside of our solar system. This very strange looking object that was it was too small to be a planet, but it was bigger than most of the comets. And it was weird because it has like these 2 different spheres that are put together, and basically all the astronomers got together and tried to talk about this thing because nobody could know what it is. They're trying to identify this mystery object that we found in outer space. If you were a geologist and you dug up rocks underground, you might sometimes come across incredible looking stones and minerals like this thing right here that's almost glowing with this beautiful purple color. It has these flat sides but also these like pointy crystals. This is a stone that someone discovered underground one day. And just like you or me, they're a curious scientific person and they want to figure out, what is this thing? And to bring things back to our current unit in chemistry, oftentimes in chemistry, Chemists have the experience of mixing together two different chemicals and producing something new. That's often what chemistry is really all about. So in this case, someone combined these two different liquids in a beaker, and this new strange yellow creation is coming out of it. And any good chemist would be asking, what is this thing? So here are 4 examples of new things that scientists discovered, and they're trying to figure out what the heck they're looking at. What is this, this bone, this gem, this thing in outer space, and so on. So, when we try to figure out what these things are, one of the best ways to figure out what a mystery object is to compare its properties to things you already know about. And that is why we've been spending so much time talking about properties, because we can compare properties to find out what mystery objects are. And this ends up being one of the most important questions that we can ask in science. It's today's big question, and in fact it's often a big question in science, just a simple question of, what is this thing? In order to help us answer that question of what is this thing and see an example of the way we can use properties, we are going to Crash Course. Listen up closely, our friend Sabrina has an interesting example for us.
Have you ever gotten up in the middle of the night to use the bathroom and stumble out of bed and then smash? And then after that, ow! Well, that has happened to me. In fact, just last night. Got up, went to get some water, and kicked something really hard. And now, my toe hurts. So bear with me. But if you're at all like me, having this happen to you likely brought a few things to your mind. Like 1, turning on the lights would probably have been a good idea. 2, what did I trip over? And 3, who left it there? The second of these questions is pretty important because it's a question that's the essence of so much science, and that is, what is this thing? No matter what that thing is, I can tell you that it's made up of matter, and all matter has properties, specific characteristics that separate it from other kinds of matter. If you remember from the last episode, properties are things we can observe and measure, things like an object's length, width, height, and volume. But how can we use these kinds of properties to identify an object? I am so glad you asked, because we're going to do a little investigation together. So today we're going to solve the mystery of what did Sabrina trip over in the middle of the night? And we'll do this by examining the properties of said mystery object, which I happen to have right here, hidden under the cloth. But before we start our investigation, did you know that there are different kinds of units that can be used to measure things? You can measure in feet, or pounds, or gallons. If you wanted, I guess you could also measure in jelly beans, but that would take a long time. So we'll just go ahead and use the International Standard Units, also known as the metric system. You might know these units as meters, grams, and liters. And the markings on my measuring tape here divide a meter into 100 smaller pieces of equal size. Each of these is a centimeter, 1/100th of a meter. Okay, now back to this mystery object. Feeling around, it's got nice straight sides, and 2 sides are larger than the other 2. That means we're dealing with a rectangle here. Now, let's give those sides a measure. Looks like it's about 23 centimeters wide, about 30 centimeters tall, and about 5 centimeters high. So we have some measurements. That's a good start, but it's not enough to tell us what this thing is. So let's measure another property, its mass. To do this, we need a different tool, a scale, and we'll use a different unit too. In the metric system, the unit of mass is called a gram. A paperclip has a mass of about a gram. Whatever this is kind of heavy. It's almost 3,000 grams. So here we have an object that is pretty heavy, hard, smooth, and rectangular. Let's see, what other objects do I know of that fit that description? Tennis racket? Nope, it's not my socks or my stuffed panda, and we've already ruled out my tablet. Oh, I know, it's my science book. I was doing a little reading last night and put it on the floor before I turned the lights out. So we've been able to identify a mystery object by observing and measuring its properties. We used units in the metric system to put values on properties such as grams for mass and centimeters for length, width, and height. And those numbers gave us enough clues to solve the mystery of what I kicked in the dark. So remember, when it comes to measuring, think metric. And when it comes to identifying objects, take a tip from me. Avoid identifying them with your toe.
Alright, thank you so much from Crash Course. We're going to hop back over to our PowerPoint, so I want to recap and run through what it is that she just did. Now, Sabrina in this video used properties to identify a mystery object. Her example was a little bit silly. She said there was this mystery object that she tripped over in the middle of the night. We couldn't figure out what it was, but she was able to measure its length, width, and height, put it on a scale, and find out that it was heavy, it was hard, it was smooth, it was rectangular, and based on all of those properties, concluded that the mystery object was her science book. That's like a very elementary or very kind of basic version of the way that scientists use properties. Now, in this case, you maybe could have just said, hey, Sabrina, turn the lights on and you can see what this object is. But when we're trying to figure out what mystery objects are in science, it isn't always that easy. So, I have a different example for you, one that's maybe a little bit more advanced, and one that I know is near and dear to many of your hearts, because when we were doing our astronomy unit a couple months back, several of you continued to ask me questions about Pluto, and about whether or not Pluto was a planet. Well, I want to talk a little bit today about how scientists decided, or you could say figured out, that Pluto no is in fact not a planet. Now here's the thing. For a long time, scientists were arguing back and forth about is Pluto a planet or is it not. There was yelling and shouting and debate all the time, and you'd have one scientist who'd say something like this: obviously it's a planet. It's just like all the other planets. A giant ball out there in space orbiting the sun. How can you not think it's a planet? And some people would feel very strongly that way. But then other scientists would say the opposite. They'd say, no way that thing is a planet. It's way too small and way too far away. There are things besides planets that orbit the sun, you know. And this went on for a long, long, long time. The people would yell and shout and scream back and forth, and they each felt that they were right, and it wasn't really getting anywhere. So eventually, the scientists said, hey, we need a better way of doing this. We need to think about, because it made Pluto very sad, so we needed a better way of doing this. And they said, hey, we need to think about properties. Here's what we should do. We're going to think about planets, and think about dwarf planets, because the people who said, hey, it's not a planet, they said instead it should be called a dwarf planet. And we can list out all of the properties that planets have, like these ones over here, and we can list out all the properties the dwarf planets have over here, and then we can go and see which list of properties Pluto lines up with best. So, they took Pluto, they took everything that we know about it, and they went through the checklist of all the different properties that a planet might have. For example, planets revolve around the sun. Yep, check that off. Pluto definitely does that. Planets are sphere-shaped, like a ball. Yep, that's true for Pluto, too. Planets tend to be either solid or gaseous. Yep, that's true for Pluto. It's a solid object out there in space. Planets tend to be at least 3,000 miles across. Well, here we run into a problem. Because if you measure the diameter of Pluto, that means how wide it is from one side to the other. It is less than 3,000 miles across. And planets, they said, they have no other objects in their orbit. In other words, like the almost circular path that a planet, if you have the sun here in the center of a solar system, the path that planets take to go around the sun, there should be no other objects in the way, other stuff sitting along that path that the planet would be crashing into. Planets should have a clear pathway to travel in their orbit all around the sun. Now for Pluto, they found that actually wasn't true either. It did have things in the way of its orbit. So it has some properties of planets, but not all of them. If you look at the properties of dwarf planets over here, they say, those also revolve around the sun. Yep, Pluto's good to go. Those are also sphere-shaped. Those can also be solid or gaseous. But those are less than 1,500 miles across. And that is true for Pluto. It's less than 1,500 miles from side to side. And those may have other objects in their orbit, which is also true for Pluto. So, having now gone down the checklist of the properties, we can finally determine that in fact Pluto is not a planet, it is a dwarf planet. And that was how the scientists ultimately decided, and that's what Pluto is. It's not a planet, it's a dwarf planet. And that also means that you don't have to feel bad for Pluto anymore. It's not like it got demoted or kicked out of the planet club. It means that it can very happily coexist with its family of other dwarf planets, like Eris and Ceres, and I think you call this one Make? I'm not sure. I've never heard about that one before. And Pluto's very happy to be there. So, you might now be wondering, back to those 4 mystery objects that Mr. Manta showed us before. Were scientists also able to use properties and figure out what those 4 things are? And the answer would be yes, because scientists use properties to identify mystery objects all the time. So for example, that giant dinosaur leg bone that they found all the way out there in France, they learned that it's 140 million years old, and that it's a sauropod leg bone. A sauropod is a big family of dinosaurs like Brachiosaurus and Titanosaurus, and it's a leg bone for one of those kinds of dinosaurs. This giant weird-looking object floating out in space, they determined that thing, they gave it the name Arakoth, and decided that it was a planetesimal. That means it's even smaller than a dwarf planet. It's like a tiny little bit of something that you could kind of sort of call a planet, but it's in this category of objects called a planetesimal. This really cool looking gem that we have up here, the scientists analyzed, and they found out that it's a kind of fluorite, which is a kind of mineral. And we've learned plenty about minerals, so that tells you something about that gem. And this mysterious chemical that we've created right now in this beaker, scientists were able to determine that that is called lead iodide. It's a chemical substance, and specifically it's a kind of precipitate. This is bonus information, you don't need to know this, but a precipitate is any time that you can mix 2 liquids together that have something dissolved in them, and you create a solid from them. So this lead iodide, this bright yellow stuff, is a kind of precipitate. And so yes, we've been able to identify all 4 of these mysterious scientific objects. Alright, that brings us to our classwork questions for today, and we actually have 2 of them at the same time. So here's what you're going to do. Classwork question 1 is to choose your own mystery object, and without telling me what it is, name 5 properties that it has. Classwork question 2 is then just to tell me what the mystery object is. So I'm going to go through and I'm going to try to identify, I'm going to try to guess some people's mystery objects just by looking at the properties, and then see if I was actually correct, and if I was correct in guessing what your mystery object is by looking at the second classwork question. And if anyone gives me some really good, fun, but tough, but able to figure out mysteries, then I'll maybe give you a shout out in the next video. If you want, you can also go into the comments for the video today and give the properties for your mystery object, and then see if any of your classmates can guess it. And you can go there and look at what your other classmates have said and try to guess other people's mystery objects too. That'd be fun. Alright, that takes us to our independent practice for today. So make sure you're in your notebooks again. You jotted down numbers 1 through 8 because here are our 8 questions. Go ahead and pause the video, and in your notebooks, complete these now. Alright, I'm assuming you've now finished the independent practice. We're going to go ahead and show the answers for each of these. Number 1, scientists figure out what mysterious objects are by looking at their properties. That is the whole big point of today. We can use properties to identify mystery objects. Number 2, you can find an object's properties by either measuring or observing. It's the 2 ways we can find properties. Number 3, the units we use to measure length, and Sabrina talked about this in the video, are meters or centimeters. Either of those answers are correct. In science, we use meters and centimeters because we use the metric system. If you said feet or inches, I'm sorry to say that in science, that's not really correct. We don't like to use feet and inches. We prefer to use meters and centimeters because everybody uses those all around the world. The units that we use to measure mass are grams or kilograms. Either one of those answers can be correct. The units that we use to measure volume are liters. We haven't talked a lot about liters so far, so a lot of people might have missed that one. That's okay. But you can often go to the store and buy like a liter of milk. It's a unit of volume. Number 6, because of its properties, Pluto was determined to be a dwarf planet because it had more properties in common with the dwarf planets than the regular planets. Number 7, red, blue, and orange are examples of the property color. And number 8, soft, smooth, and rough are examples of the property texture. That's like how a mystery object feels. Both of those things are things that you could use to identify a mystery object. Go ahead and star the questions that you got correct, fix those answers you got wrong, and then yes, in today's classwork form you will be checking off all the questions that you got correct. Alright, and ladies and gents, that's all we got for today. That takes us to our exit time, as well as a very exciting announcement. So, here's the deal for today's cool thing. I had mentioned in yesterday's video that if people were interested in it, we could maybe try to do a video chat so everyone can say hi to each other and see their classmates that they miss. Now, I'm still trying to work out the technical details of how that would work. And I know some people are saying Google Hangouts or Zoom or all these other choices, and there's kind of problems with each of those that I'm trying to work through. But instead, what we're going to do, at least for now, is use a website called Flipgrid. Now, the 6th graders, I think you've already used this, and Ms. Corrier is basically doing this with you, so I haven't made a Flipgrid link for the 6th graders yet. It's only for 5th grade right now. 6th graders, if you want to do a science Flipgrid, then let me know in the comments, and I can do one specifically for you guys. But 5th graders, here's how this works. I'll show you really quick. If you come to today's Google Classroom, and here on Thursday, April 16th, you will have this little optional assignment that says optional upload a Flipgrid video, and I write out the full instructions right here. But the basic idea is to go to flipgrid.com, which is the website that you can link to right here. When you go to Flipgrid, you will see, you will see a page that looks like this. And you're going to come down to this box right here where it says enter a flip code and enter our class code. Our class code is my last name, Manta1234. And then you're going to press enter. You're going to have to log into your Google account so it will be connected. And once you do that, you will see a page that looks like this. This is the Flipgrid 5th grade science page. What Flipgrid is we can't like live video chat with each other, but everyone can upload these short little videos to say hey to their friends, and then you can go and watch each other's videos. So you're going to come down to the bottom of the page here, click the big green plus button, and then that's going to open up a page where you can, if you press allow, it will go to your camera, and you can record a video up to 5 minutes long to like say hey to your friends, say what's up, and greet anyone that you want to greet, and just kind of have a good time chatting with your friends. I put some optional question prompts if you're trying to think of what to say, like if you're missing school or not, what time you've been getting up and going to bed, that kind of stuff. But all of this is optional. It's just a way for you guys to make some fun, cool little videos and say what's up to your classmates. Alright, that's all we got for today. Make sure you knock out classwork, exit ticket before you go and upload a Flipgrid video. But I look forward to watching all your guys' videos. How about if you can make me laugh, plus 5 scholar dollars. Alright, take care.